Good afternoon, class. Thank you. You can sit down. All right, then in today's lesson, hopefully we'll be looking at what scatter diagrams are and how to draw lines of best fit after we've looked at the homework that you were given to complete. Okay, the correction of the exercise on linear models, I think we completed question 1, and we were halfway through question 2. Okay, the question was based on the graph that is shown on the screen, the length of a spring with mass attached to it at its lower end. The equation of the line was y equals 2x plus 15. Okay, we answered letter A. What is the length of the spring before any mass is attached to it? The answer was 15 centimeters. That's when there is no weight or mass attached to it. That's when x is 0. And then the next question was, find the length of the spring when a mass of 5 kilograms is attached. And we said that it was 25 centimeters. And the extension was 20 centimeters. Okay, letter C. We are now up to letter C. What is the amount of extension in the spring with a mass of 11 kilograms attached? Anyone with an answer to the question? Capin, what's your answer to letter C?
22 centimeters.
22 centimeters is correct. Next question. If the spring has a length of 29 centimeters, what mass is attached? Margaret?
Seven kilograms.
7 kilograms. Good. Letter E, if the spring is extended by 8 centimeters, what mass is attached? Megan?
Four kilograms.
4 kilograms is correct. All right, then you were asked to do question 3. The average speed of John Glenn's space capsule around the Earth was approximately 10 kilometers per second. Okay, D is the distance in kilometers traveled by the capsule in T seconds. Complete the table of values below. Andrew, can you give us the values for D that are missing in the table? When T is 2,
when T is 2, D is equal to 20 kilometers. When T is 3, D is equal to 30 kilometers. When T is 5, D is equal to 50 kilometers. And when T is 8, D is equal to 80 kilometers. And when T is 10, D is equal to 100 kilometers.
okay? Right, putting T on the horizontal axis and D on the vertical axis, plot the pairs of values for T and D and complete the graph. Now, if you've got a correct graph, your answers to letters C, D, and E must be correct. Okay, for letter C, from your graph, find the distance traveled by the capsule in 4 seconds, in 7 seconds, and in 9 seconds. George? What's the distance traveled in 4 seconds?
40 kilometers.
And 7 seconds?
70,
And 9 seconds?
90.
90 kilometers. Correct. Letter D, from your graph, find approximately how many seconds it took the capsule to travel 58 kilometers and 82 kilometers. Livingston.
.8 seconds and 8.2 seconds.
5.2 seconds and 8.2 seconds, correct? And letter E, calculate the speed of the capsule in kilometers per hour. Esther.
Thirty-six thousand kilometers per hour.
36,000 kilometers per hour is correct. Question number 4. The graph shows the cost for printing business cards. For example, 100 cards would cost 250 cents or $2.50. You can tell from the graph, this is the number of 100 cards, and going up, that's 200, 300, 250. So 250 cents, or $2.50. All right, with that in mind, you'll have to answer the following questions. Jake, what is the cost of printing 400 cards?
$4.
Are you sure? Okay, correct, $4. Letter B, how many cards would be printed for $5? Garonamo?
$600 cards.
600 cards is correct. The equation of the cost graph is in the form C equals mx plus b. X represents the number of cards and C represents the cost. Find M and B and use the formula to find the cost of printing a special order of 1,200 cards. Hekoi, what is the equation of the line?
C equals half x plus 200.
C equals half x plus 200. You all got half x plus 200? True. Daniel, is your answer C equals half x plus 200? It's correct. C equals half x plus 200. Use the equation to find the cost for 1,200 cards. Daniel, your answer, please.
$8.
$8 is correct. Okay, that was the homework you were given, and you did very well. Any questions? No, it's just a matter of understanding the graph and reading from the graph. Okay, you will note that all the graphs that you were given, it was very easy for you to find the answers. One, because the equation was already given in the form y equals mx plus c. And secondly, you were given some values and you had to work out the equation of the line. And then you answer the questions from there. The next thing we are going to do is slightly different. Right? We are going to look at what is called scatter diagrams. And from scatter diagrams or scatter graphs, you're going to draw lines of best fit. Okay, this is my own definition of scatter diagram or scatter graph. I am not a mathematician. All right, I just teach maths, but I'm not a mathematician. Okay, a graph that is plotted using results from experiments where the points don't necessarily lie on a straight line. Because in an experiment, you can make mistakes, and like the other graphs that you've looked at, all of them lie on the same straight line. Usually it doesn't happen that way. Okay, if you, let's say, we measured the heights and the ages of a group of children that live on planet Pluto. Okay, on planet Earth, first let's start off with children on planet Earth. If I put age on the horizontal axis and height on the vertical axis, usually as you grow older, your height is supposed to increase as well. So we may have, let's say we are measuring the heights and ages of maybe children in elementary school. Okay, the points might look something like this. They won't all lie in a straight line, but they will be something like this. That means that as you grow older, your height is supposed to increase as well. When you come up, this is called a scatter diagram or a scatter graph because the points don't lie on the same straight line. But they lie towards the positive direction. So this is called positive correlation. It means that the age and the heights are related in that the older you grow, the taller you should become. That's not really true for some people. Okay. But that's graph number one. Second graph. If we went to an alien planet, when you are born, you are very tall. And as you grow older, you grow shorter. Okay, there are some things that you can compare, and you will have a graph like this. Like for instance, if you travel at a faster speed, the time will get smaller. The time will decrease. I mean, you travel faster, you're supposed to travel at a shorter time than if you travel slower. So those two they'll correlate in this manner. But I'm just trying to make you laugh by saying that if we went to an alien planet or planet Pluto, if there are some human beings there, and they are born very tall, and when they turn 50, they are very short. Okay, this is negative correlation. Okay, we decide to take the space ship and we go to another planet. This time, the ages and the heights of people who live on that planet they're not related at all. So you're very young, very short. You can be very young and very tall. Or if they are not related in any way, the points will be scattered all over the place. Okay, for this one, there is no correlation. That means there is no relationship between the age and the heights of those people who live on that particular planet. So no correlation. On the other hand, okay, let's say we keep traveling and we come to another planet. I don't know. Now, those people, when they are born, they are the same height. They don't grow taller as they grow older. Okay, this is where you have zero correlation. Note the difference between no correlation and zero correlation. No correlation means the two things that are compared are not related in any way because they don't form, they're not correlated, whereas this, it's just the same. Now, note the way these are related to the gradient of the line. This is a positive gradient, this negative gradient. This one is a horizontal line which has a gradient of 0. This there doesn't seem to be any gradient or any line formed. Okay, that's the first thing. Now, the next thing that we are going to look at is you are supposed to be able to draw a line through any quantity that you plotted, any graph that you plotted that are related. Like, for instance, you can draw a line through this and then estimate the gradient of the line which the points are lying. So as here, that line is called the line of best fit. It's not the true line of the points or that shows the way the points are lying on the graph, but it's just called a line of best fit. Okay, on your worksheet, I think it's question 6. Just locate it on your worksheet. I've got the same example on the screen. Okay, the famous spring. A spring is fixed at its upper end, was stretched by applying to its lower end some mass. The table gives the readings obtained. X is the mass in kilograms, and Y is the length of the spring in centimeters. Okay, the values are plotted on the graph below. Okay, so when X is 2, which means when the weight was 2 kilograms, the mass was 2 kilograms, Y is 10, and so on up to 14 and 38. All right. This is an example of a scatter diagram. That means it's positive. It represents two things that are positively correlated because the points lie towards the right. All right, to draw the line of best fit, this is what you are supposed to do. 1, you're supposed to calculate what is called the average point. Let me just go back. Now, to calculate the average point, I hope you are listening. You add the sum of all the numbers and you divide by the number of those numbers. So you add 2, 3, 4, 6, 8, 10, 12, and 14. You divide by 2, 4, 6, 8. The same goes for the Y values. You add all of them and then you divide by the number of those scores. So that's the first thing you do. You find what is called the average point. It's called the average point. It's also called the mean point, and it's called the pivotal point. But I always use the average point. But in case those two other names are used, it's got 3 names. Okay, then the next thing you do is you plot that point on the graph. It is not on the table of values, but usually what happens is that when you calculate it, it will be somewhere right in the middle. Okay. Then the next thing that you do is to draw the line of best fit. And that line of best fit actually passes through the average point. Okay, I'm going to do an example a little later on the chart. But what I've done is I have shown the average point somewhere here, and it happens to be, I think, 7.4, 24.4. You can check by trying to calculate the total and then divide by the sum. Now, what I did then was to draw the line of best fit through the average point. Okay, I can't actually do a perfect one on the graph here because you see that this average point is a little bit lower, but it should go through, the line should go through the average point. And the way to do it is this. You have to put your ruler on the average point, and you don't just put the ruler and draw. You have to move your ruler around a bit so that when you see that many of the points are close to the line, then you draw the line of best fit. It's quite difficult to do. Now, in science, they probably don't calculate the average point, but in maths, it's a must that the average point is calculated. It makes it easy for us to find the equation of the line. So I put here, put your ruler on the average point and move it around a bit until many of the points are either on or close to the line. Then you draw the line. Okay, the average point, I've just indicated the average point here again, and it's the total of the scores divided by the number of the scores, or the number of the numbers. Okay, I've got the same one on the chart, and hopefully this will go on to the board. Okay. I plotted the same points, the same one on the screen. I've got it here, and I'll just show you how to draw it. Okay, if you note, you plot the points first, then you come up with the scatter diagram, then you calculate the average point. After you've calculated the average point, you plot the average point, and note that it's always somewhere in the middle. And I've calculated it as 7.4, 24.4. And then, okay, I could have easily just put my ruler like that and then drawn the line. But it won't be a good one because then many of the points are not close to the line. Okay, I've seen a student some years ago, he just went ahead and drew a line like that. And that line doesn't represent the slope or the way the points are lying on the graph. Okay, you have to draw the line that's right in the middle. Some people say that there will be equal number of points on either side of the line. I actually don't really agree with that. That happens, but not always. So long as what you've done is you put the ruler on the average point, and you have to move the ruler around a bit so that you see that there are some points close on this side, there are some on the other side, and then you draw the line of best fit. Okay, the next thing that happens after you've drawn the line of best fit, many times you'll be asked questions relating to that. So I've got the questions that follow. Now it says the length of the spring can be represented by the equation y equals mx plus c. Y represents the length of the spring in centimeters, and x represents the mass in kilograms. Now what we are going to do now is to find m and b. M is the gradient, and b is the point where the graph cuts the y-axis, or the vertical axis. Note also that in experiments, this will not always be x, and this will not always be y. So you have to use also the letters that are used here, whatever goes here and here. It could be T, it could be C, but make sure you don't get used to just using y and x. Okay, to find m, m is the gradient of the line. Now what do I do to find m? Anyone? How do I find M? Come on, you all know. Don't all go to sleep now. No time to go to sleep yet. Peter.
Rise over run.
Okay, in this case, you tell me, how can I calculate the gradient of this line? Am I sure? Can I be sure what the y-intercept is? Okay, because of the grid that I have shown, that I've got, I cannot use the y-intercept. If I can, I'm able to. Let's see, this is 5, this is 7.5, because I've got two intervals. This is 2.5 and 5, 2.5, that's 7.5, and then that's 10. Okay, can we estimate this point? Is 7.5, between 7.5 and this space is 2.5. 8.25? Okay, let's see, we can take it as 8.25. Now, to use rise over run, note, please listen, you don't choose any points on the table of values, like the table that's on for this graph. You don't choose any points on the table because, as you can see, none of the points are on the line except the average point and this point. So don't choose any points on the table of values unless that point is on the line. So you just choose 2 points that are on the line. If I choose this one, okay, usually you should be doing this on a graph paper so you know exactly what your intervals are. Okay, and then I draw a right angle triangle. Okay, if this point is 8.25, now what is the rise? Oops. Livingston? $24.4 take away 8.25. What's the rise? Yes?
16.15.
16.15, and the run? The run will be 7.4 because it's from 0 to the x coordinate of this point. So 7.4. Okay, very quickly, the gradient will be 16.15 divided by 7.4. 2.2? Okay. So the equation of this line will be y equals 2.2x plus 8.25. All right, next question. If this equation holds true for larger messes, find the length of the spring if a mess of 20 kilograms is attached. All we have to do is substitute 20 for x. So we will get y equals 2.2 times 20 plus 8.25. Is 2.2 times 20, 44? 44 plus 8.25, 52.25. Okay, very good. Now, the question that you will do for homework is question 1, question 2, Sorry, the questions are question 1, question 2, question 3, and question 4 and 5. All right, the key word to the pilot teacher is best fit. Please stand. Good afternoon, class. Thank you.